So numbers 1 and 2 are the start of those linear inequalities, right? So for number 1, I'm going to start by distributing what's on the outside to the inside of the parentheses. So I'm going to do 2 minus 8x is less than negative 2x minus 6 minus 4. Combine my like terms there on the right side. And then I want to get both x's to the same side, so I can add the 8x and then add the 10. 12 is less than 6x, divide by 6. 2 is less than x, or x is greater than 2, is my inequality statement. If I was to graph this on a number line, it'd be 1, 2, 3. Greater than is a parentheses or a bracket? Parentheses, good. So parentheses shaded to the right. And then my interval notation matches that. 2 parentheses, infinity. So as we start to prepare for the test, start to think about how this would be written. This answer would be written in interval notation, no spaces, and the word infinity is going to be used in the place of the actual infinity symbol because you can't get to the symbols. So just think about how you would write that, yeah.
So I kind of forgot, what's the rule where you have to switch the sign?
If you divide or multiply both sides of the inequality by a negative number, then you switch the direction of the sign. Yep. Yeah. Audrey.
Can we do this on the paper too?
Yeah, I'm going to give you guys paper and you could do it right on paper. Absolutely. Okay. See what happens if you stay at home? You lose the infinity. Just think about it. Group this. All right. 2. Now there's no parentheses, but this is your compound inequality, right? Whatever I do to the middle, I have to do to both sides. So I'm going to add the 12 middle and both sides. Negative 21 is less than or equal to negative 7, which is less than negative 14. 7x. Now, divide both sides. Wait, hang on, let me grab a different color. Divide all 3 parts by a negative 7. So Madison is piggybacks on what you just asked. That switches my signs. Negative 21 divided by 7 is 3. The sign flips direction. X flips direction 2. Now notice one of them has got an or equal to, the other one doesn't, right? So be really, really careful when you're rewriting these steps that you don't lose something like that, okay? Because that's important. Also notice that my biggest number is on the left. So if I wanted this to make sense numerically, I need to switch the order. 2 would go first, then x, then 3. The bigger part is pointing towards the x here, and then towards the 3 there. So x is greater than 2, but less than or equal to 3. On a number line, 1, 2, 3. Greater than 2 is a parentheses on the 2. Less than or equal to 3 is a bracket on the 3, shaded in between. And then my interval notation is going to match that. 2, 3, bracket on the 3. Jeez Louise. I mean, I'd rather it happen during the week than over the weekend, I guess. But it is coming down. Questions on that one? Yep.
Why wouldn't you put an infinity at some point in the step?
Because there's a lower number, and so it's in between those two numbers, right?
Then you don't put
If it's shaded in between, no infinity. If it's pointing out, that's when you get those infinities. All right, number 3, now we've got absolute value. So remember the rule on absolute value is get the absolute value isolated by itself. Read that statement aloud or in your head. And if it's greater than, which this one is, it becomes an or statement, right? So great or is or, which means I'm going to put a positive 11. Actually, look at this one. What do I know about this? Say again. Close. But the opposite direction. What's true about every absolute value? It's going to be positive. What's true about a positive being greater than or equal to 11? Is there any positive number that's not greater than or equal to 11? No. So this is actually an all real numbers scenario. Okay? Let's pretend we didn't catch that. So all real numbers is negative infinity to positive infinity. Yep. So greater than or equal to negative 11, right? is what we're looking for. Whatever comes out of that absolute value is going to be 0 or bigger than 0, right? Which is always greater than or equal to negative 11,
Oh, okay.
right?
Okay, I get it.
If you don't catch it though, let's just say we were chugging along, right? I would put the opposite number on the other side, 11 greater than or equal to 1 minus 4x, or 1 minus 4x is greater than or equal to negative 11. Then I keep going, -1, -1, 10, greater than or equal to negative 4x, divide by negative 4, flips the sign, 5/2, less than or equal to x. Do it on the right hand side, subtract the 1. Divide by negative 4. Okay, so put this on a number line so we can get a visual here. 5/2 is 2.5, yes? So it's saying that it has to be greater than, right? X is greater than or equal to 2.5. Actually, let me shift this over, put 3 there. Greater than or equal to 2.5. Everything there to the right. Yep.
Over there, why isn't it like 5 over negative 5 over 2?
This should be switched. Sorry. Say that again.
Why isn't it negative 5 over 2?
Ah, negative 5 over 2. There we go. You're good. Thank you. Then on the right hand side, we've got x is less than, because the sign switched because I divided by a negative, less than or equal to 3. That gets a bracket also, points to the left. Now if it was an and statement, it's only where these two overlap, but it's an or statement, and I have shaded that entire line, which is the same thing as saying all real numbers. So if you do catch it from the beginning, you're going to save yourself tons of time. If you don't, then you go through the work, but you should still get the same answer. Yep.
So how do you know it's all real numbers?
If its absolute value of something is greater than or equal to 0 or anything less than 0. Then it's all real numbers, which is negative infinity to positive infinity.
So then how do you know this is a solution?
If its absolute value is less than 0 or anything less than 0, now it's no solution. Which on your test you'll put NS. Does that make sense? Yeah. And if you don't catch it, you could go through that work. If it's an and statement, nothing will overlap. And if it's an or statement, everything will overlap. Or not everything will overlap, but you'll shade your whole line. So let's work through 4. First thing I have to do here is subtract the 6. Then I have to divide by 9. Not divide. Holy moly, I subtracted, sorry. Okay, now it's greater than, this would be negative 5. Right?
Yeah.
Oh, this is positive. This is positive. Because if I divided by a negative, I would have, yeah. Okay, that's positive. Now it's negative 5 and 5. And it's great or, so I split this into 2 statements. So then I would add the 2, divide by 3, x is less than negative 1. On the right hand side, add the 2, divide by 3, or x is greater than 7/3. And again, it's or, because the original statement, once I got the absolute value on the side by itself, is read as great or, right? Greater means or. So then my number line, -1, 7/3, which would be 1 2/3, less than -1, points left with a parentheses, greater than on the 7/3 is a parentheses pointing right. In interval notation, this is negative infinity to -1, union 7/3 to positive infinity. So again, if you're thinking about how would I write that in a fill in the blank, I would do parentheses, negative infinity, comma, -1, close the parentheses, and I will either put a U, a semicolon, or a comma. I don't care what you put there, I put all three answers would be right, okay? If it's a U, it's literally the lowercase u. You could also put a semicolon, you could also put a comma. I would mark all of them right. Then parentheses 7-3, because it's a fraction, infinity. Close the parentheses. So that would be if it was fill in the blank, so I don't know why I'm talking to the people in front of me, but the people at home, that's what it would look like to mark it correctly and fill in the blank.
How would we graph like a no solution?
It would be an empty line.
Oh.
Okay, good question. The question was how would you graph a no solution, and it would be an empty line. Yep.
Can you say which of the rules are all real and then no
This one here. Good.
Why was it negative infinity? Oh,
Because the arrow was pointing left, right? We said less than.
okay, yeah.
Yeah, we said less than -1 or greater than 7/3. Okay, so today's are 1/8, which is still inequalities. Again, good, because it's forcing us to practice the inequalities. It's going to force us to practice the interval notation, all that stuff we'll keep practicing. But now we add in quadratic inequalities. So what happens when we add in quadratic is we usually factor or last result have to use quadratic equation. So these are a little bit different in the way that we solve them, but we're still using the same rules of inequalities. So the first thing we're going to do is get it so that our inequality, whatever's on the side, is less than or equal to 0, or greater than or equal to 0, or less than or greater than 0. We want 0 isolated on the side by itself and everything else on the other side. Then we're going to solve it as though it did say equals. Most likely this gives us 2 points, because if it's a quadratic, 2 answers. Then we call this test point. We set up a number line with one number here, one number here, and we plug in points from the different ranges on our number line to see which of those points satisfies my inequality and which do not. And there is usually a pattern, there are exceptions, but there's usually a pattern which we'll get to when we go over it. It's usually like an and or an or, so it's usually shaded in between or shaded on the outside, but again, there are exceptions. We'll talk about them when we get there. And these are going to be given in, again, interval notation. So we'll graph them and then we'll give our answers in interval notation. All right, so let's start with 1. Solve, write your answer in interval notation. Already, 0's isolated on the side, right? So I don't have to move anything yet. How do I solve x squared minus 2x minus 3?
Quadratic formula?
You could do both. So quadratic formula is an answer, but factor is probably a faster one. You can do both, but factor is probably faster. So I'm going to do factor. X and x, factors of -3 that sum to -2. -3, +1. Solve it as though it was equal to 0. So set these each equal to 0. And I get x equals 3 and x equals -1. Set up a number line. Plot my -1 and my 3 in order from least to greatest. Plug in a point that is less than -1, like -2. Plug in a point in between -1 and 3, make it easy, like 0. And plug in a point bigger than 3, like 4. So you're grabbing any point from the range there. By plug it in, I mean plug it in to here. So I'm going to get -2 squared minus 2 times -2 minus 3 is less than 0. 4 plus 4 minus 3 is less than 0. 8 minus 3 is less than 0, and 5 is less than 0. Is that a true statement?
No.
So I rule out that portion of my number line.
Okay, I was thinking,
What are we doing, right? Then I go to the next one. So here I'm going to plug in 0. 0 squared minus 2 times 0 minus 3 is less than 0. 0 is gone. 2 times 0 is also gone. Negative 3 less than 0. Is that a true statement?
Yes.
So then this portion's going to work. Go to the next one. Plugging in 4 this time. 4 squared minus 2 times 4 minus 3 is less than 0. 8 minus 3 less than 0. 5 less than 0. True statement? Nope. Rule that portion out. So I know I'm talking about the middle part of this graph, just like it was an and statement. Do I put parentheses or brackets on this? Parentheses because my original sign is less than. So less than, shaded in between. Interval notation would be -1 to 3.
So how will you know which specific numbers to plug in?
You can plug in any points from the range you have set up, Ethan. So if I wanted to plug in something from the left side here, I just need something less than -1. Something in between -1 and 3, usually if 0's in the range, I pick 0. And then something bigger than 3. It doesn't matter what specific number you plug in as long as it falls within that range. Now, usually these take on the same characteristics as our absolute value. So if I read this part out loud, it would have been blah, 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 is less than 0. Yes? If it was absolute value and we said less than, what kind of problem is it? It's an and statement, which is usually shaded in between. That rule gets broken if there are more than 2 roots. So if we have a third root, it's broken. That rule also gets broken if a root repeats. So if we have the same root twice, obviously it can't work. Okay? So if it was great or, it's usually or.
What would this answer look like on the test?
Just like this. Parentheses, -1, comma, no space, 3 parentheses.
But we wouldn't graph it?
Nope, it's just going to say give it an interval notation.
Okay.
The homework's going to ask you to graph, but the test would not.
Okay.
I think if you were given it in person on paper, you'd probably graph it, but on Canvas, we're not going to have you graph it. All right, so this one, again, already set equal to 0, right? So I'm going to factor. This time, factors of -6 that sum to -1, -3, +2. Split and solve. Test points, -2, 3. Our gut tells us what should this be? Read the initial. Less than or greater than? Less than, and so we think it's coming from this section. So let's test a point. 0 is the easiest one there. 0 squared minus 0 minus 6 is less than 0. -6 is less than 0, and we're right.
Will only one of them work?
It's alternating what will work. When you have 2 points. So either the middle's going to work or the outside when you have 2 points and it's quadratic, yeah. We're going to get into when it's fractions, it's different. And we're going to get into if you have 3 points, it's obviously different.
So to check these ones, you wouldn't have to plug in all 3, you only have to plug in at least 1.
Right. And you could, again, that's only if you have 2 roots and they're unique. They're not the same root. Yep.
Would it ever be one side would work with the other side wouldn't?
If it's not 2 points. If you have 3 points or a repeated root, yes. Yeah.
So what do you mean to use?
Say again? Like if I got -2 twice.
Oh, okay.
Now it's going to be different because there won't be 3 intervals there, right? It's either going to be the right side or it's going to be the left side.
Wait, so you don't even have to test?
You'd have to test one or the other.
But in this case, you don't have to test the other side?
I would test it to check, but I don't have to test it to get that answer.
Oh.
Yeah,
But to get the answer, you have to check at least 1.
correct. Well, I mean, you could go off your gut, but if your gut's wrong or if you screwed up a sign, you're in big trouble, right? All right, so here, I'm going to do one more on this. Actually, let's go to 4 because they're both greater, right? That tells me this is an or statement. That means my ors are going out, right? So I'm going to, you guys like first and last, right? So let's do first and last. 4 times -6 is -24. Factors of -24 that sum to -5 would be +3, -8. Plug those in place of the middle term. 4 x squared plus 3x minus 8x minus 6. Factor by grouping. Solve it. I get 2, negative 3/4. So we said we think this is an or. It's still not or equal to, which means it would be parentheses pointing out. But we're going to test points from there to be sure. So what is something that is less than negative 3/4? And God help you, do not plug in fractions if you don't have to. Yeah.
Wait, for that one, how do you know, like, which, oh, never mind.
You sure?
Yeah.
Okay. What's less than negative 3/4 that's easy to plug in?
Negative
1. So let's plug in negative 1. 4, negative 1 squared minus 5, negative 1 minus 6 should be greater than 0. 4 times negative 1 squared is 4 times 1. Negative 5 times negative 1 is positive 5. 4 plus 5 minus 6. 9 minus 6, 4. 4 is greater than 0. And then I would check that other side. Bigger than 2 could be 3. 4 times 3 squared minus 5 times 3 minus 6. Also correct. So my interval notation is negative infinity to negative 3/4 union 2 to positive infinity. Again, the little symbol in between could be a U, a semicolon, or a comma, and it will mark them all right. And again, on the quiz, you're going to have to spell out those infinities. So negative in word infinity, comma, negative 3/4, parentheses, U, parentheses 2, comma, the word infinity, close the parentheses again. Oops. Questions so far? So again, I'll work out that last one on the video.
Wait for the negative 3/4 one. Oh, you just plug in negative 1 instead.
Yep, anything that's smaller than negative 3/4.
Okay, and then for when they're not when it's and, when they're or.
Which is this one.
Which is the.
Greater.
Yeah.
Yep.
Which is like, not the first example, but this example, you do the either negative or positive infinity depending on which direction it goes. But
Correct.
The other one, it's only two grades.
So if you have parentheses or brackets and you're shading in between, there's no infinity in that answer. There's two numbers and it's in between, so it's just one comma the other one.
Okay.
But if your ors are going out, if they're going out, they're going to be negative infinity on the left side, positive infinity on the right side. You're welcome. Okay, I know it's out of order, but we're going to work out number 3 now. So it's already set greater than or equal to 0. Greater means I think this is going to be an or. Okay. Factor x minus 5 and x plus 4. Set them each equal to 0. X equals 5. X equals negative 4. Set up my number line. Negative 4 comes first. Or means it's going to be these. So I'm going to test a point that is less than negative 4, like negative 5, greater than 5, like 6. So do negative 5 squared minus a negative 5 minus 20, greater than or equal to 0. And then 6 squared minus 6 minus 20, greater than or equal to 0. 25 plus 5 minus 20, 30 minus 20. 10 is greater than or equal to 0. 36 minus 6 minus 20, 30 minus 20, 10, greater than or equal to 0. So they both work. It gets a bracket this time because it's or equal to, and I shade out negative infinity, negative 4, 5, positive infinity. And again, in between can be the U, a comma, or a semicolon. Canvas will take all 3 answers. Okay, so it's something like 5, let's say. I'm not set equal to 0 yet, right? So the first thing I have to do is get it equal to 0 or get it less than 0. I have to move that 12 over. But I also have to get rid of these parentheses. I cannot split these and say x equals 12 and x plus 1 equals 12. That doesn't work. It only works if it's 0. So I'm going to distribute the x. X squared plus x is less than 12. Move the 12 on the other side. X squared plus x minus 12 is less than 0. There's that less than again, so we think it's what? And, which means in between, right? Factor it, x plus 4, x minus 3, and I get negative 4, positive 3. Set up my number line. Negative 4, positive 3, we think it's happening in between, which would be 0. I could either plug it into the original or to my shifted one. It doesn't matter. So if I did it in the beginning, I get 0 times 0 plus 1, or 0 times 1 is less than 12, and 0 is less than 12. So I do the parentheses on the negative 4, the positive 3, and we shade in between, interval notation, parentheses, negative 4, comma, positive 3, no spaces, parentheses. And again, if you wanted to double check, you could plug in points less than negative 4 and greater than 3 and see that they don't work in that inequality.
So what do you mean by in before you shoved it in, you're like, oh, I think it's gonna go in between? How did you think this like that?
Because when you get it set up, it's actually happening here, but when I get it set up so that it's in a relationship with 0, I read that out louder in my head, and that says that whole polynomial is less than 0. So just like with your absolute value, less than is and, great or is or.
So that means it's gonna go.
And is in between, or is outside, like the oars on a boat. Yep.
You don't need to like determine that beforehand.
No, it just helps you.
Oh.
Yeah, it just helps you. Yeah.
But it'll always, okay, it's not gonna be like all three, right?
There, if a root repeats or there's 3 roots, it changes the rules. Or we get into fractions, which we're going to do tomorrow. It changes the rules. But for these standard quadratics, no. Okay, so look at 6. Again, not equal to 0. So the first thing I have to do is move the 16 over. Now that's or. We think it's going to go out. So I factor it. Plus 4 minus 4. It's a different 2 squares. Set up my number line. Something less than negative 4, like negative 5. 25 is greater than or equal to 16. And then we think something bigger than 4, like 5. 25 is also greater than 16. So this time it's an or equal to, so it gets a bracket, points it left, bracket, points it right. Negative infinity to negative 4.
Team for boys and girls have canceled their practices for today.
These last two, again, I'll work them out on the video, okay? But what do we notice about this one? Quadratic formula. So we're going to have to do the quadratic formula to get our markers, whatever point and point, okay? Which means to try to figure out where to test point, you're going to have to approximate what that point is. So you're going to do quadratic formula to get the A and the B, whatever those points are, and then test your points. But we think it's going to be greater than, which means out. This one is what I was talking about when you could get more than 1 0. I mean more than 2 zeros. So when I factor this by grouping, take out an 8 here. Nope, 16. This gets factored even further. Now I have 3 test points. 3 halves, negative 4, positive 4. So first comes negative 4, 3 halves or 1.5, and positive 4. It usually, again, is alternating, but you're going to have to plug points in here because there are 3 roots, so it doesn't follow the rules of our normal rules, the in and out. So I'll tell you right now that what works for this one, when we plug it in, is in between here and here. So that would be negative 4 to 3 halves, union 4 to positive infinity. And that's how you would write that. So it changes the rules on the and or the or when you have 3 roots like this, Or if you have one root that's repeated, okay?
You get an and an or?
You can get, well, this is still an or. It's just that there's two, it's, yeah, right, like it's an and there and an or, yeah. That's only, so just to reiterate, what I would have done here is plugged in something from this range, which 0 falls in here. And I can plug it in up here, or after you shift everything over, like here, it doesn't matter. So if I did that, I'd be 2, 0 to the third minus 3, 0 squared minus 32, 0 plus 48, greater than 0. This is gone, and 48 is greater than 0, so that works. It's usually every other one, but if I had plugged in a point here just to check, that would be 2. 2 to the third, minus 3, 2 to the second, minus 32, 2 plus 48, greater than 0, 2 times 8, 3 times 4, 16, 4, negative 60, negative 12 is not greater than 0. So I know that that section doesn't work, and then plug in something like 5 from here, and you would also see it work. So I know that it's every other segment, and then you just have to test points to figure out which one. Okay, now I'm going to work backwards and finish number 7. So I would get x squared plus 4x plus 1. This is not factorable, so I have to do the quadratic. Negative b plus and minus the square root of b squared minus 4 times a times c all over 2 times a. 16 minus 4 over 2. So now this gets broke down into 4 and 3 or 2 and 2. So this would be 4 plus and minus 2 root 3 over 2, negative 2 plus and minus square root 3. So now when we set up the coordinate points, negative 2 minus root 3 is going to be smaller than negative 2 plus root 3. But to figure out what exactly falls in between, we've got to approximate this. So root 3 is close to root 4, which makes it like a 1.8. So let's say the first one is negative 2 minus 1.8, which is like negative 3.8. And then negative 2 plus 1.8 would be like a negative 0.2. So negative 3.8, negative 0.2. I think it's going to be greater, which means or points out. So bigger than that, the 0 is actually over here. So let's test the 0. 0 squared plus 4 times 0 plus 1. And I get 1 is greater than 0, so it works. That side's going to work. Greater gets a parentheses pointing to the right. And then something less than negative 3.8. Let's make it like negative 4. And plug that in. Negative 4 squared plus 4 times negative 4 plus 1. 16 minus 16 plus 1, and 1 is greater than 0. So my or works again, points out, negative infinity, negative 2 minus root 3 is going to stay just like that, union, semicolon, or comma, negative 2 plus root 3, positive infinity. And there's the answer for number 7.